first idea of the demonstration was that in a couple of the meetings of the Red Cross, we noticed in all the well training we have here, we deal very little with electricity as far as our training is concerned. And one of the things are in the American Red Cross, when we do have a disaster and do disaster assessments of, say, a tornado or such, we'll be out in the field. There's a lot of things out there that to be aware of, and this electrical demonstration will prove to be very, very interesting to you when you're out in that situation. So at this time, I'd like to introduce, we have here Daryl, must be a good guy, he's got a name like mine.
This is where my other brother.
That's right. Daryl Dunsmore and Carl Johnson, and I'll let them take over now, and I think you'll have a very exciting and entertaining episode here. Thank you.
We prefer money. We're having to do a couple of things here real quick before we get started. By law, I have to test my equipment before I use it, so bear with me for just a second. But as Daryl said, that is Daryl Dunsmore and I'm Carl Johnson. We're both journeyman linemen, and we have climbed the poles in the past, and now I work in an office downtown Detroit in corporate safety. And I live in Port Huron with all you nice people, and I drive that every day like some other poor dumb people. Is that a good word? Dumb? I don't know. But anyhow, there's a bunch of us that drive to Detroit every day and do our jobs down there. And my job in corporate safety now is to write those stupid rules. You know, the guys that write those stupid rules, why do they ever come out with that? Well, the reason that we do that is so that we can prevent another accident from happening. Some of you work in power plants or around, and probably you have some rules out there that call for eye protection. You think, why do I need those? It's because somebody lost an eye. So that's kind of what we do. We write the stupid rules. We have an opportunity to come out with nice people like you on occasion. No, I don't do this as a job. This is an occasional thing that I get to do as part of safety. Come out with the public, and I really enjoy doing that. We're very informal, so as we're going through this, if you have a question that you want to ask, please do so, and I'm sure Daryl will give you an answer. Okay? I'll tease you a little bit tonight, so if you don't like to be teased, I'll stay away from you. I'll find out very quickly, I'm sure. But we're going to ask for some help later on to come up here and participate in this. And so we're going to need somebody that's young and strong and would like to climb a pole and do all the stuff. You're volunteering her already.
Right. Said right
there. Really?
She's the Girl Scout, always ready.
At least she had the guts to sit in the front row. Most of you thought this was a church session because you're sitting way back there in the back. So later on, the back row is going to have to sing us a song. Okay? Okay. But as Daryl said, the demonstration is to make you aware of electricity and what electricity will do. It's not a scare show. We didn't come out to scare you about electricity. We don't want you to be afraid to plug those appliances into the wall. In fact, we encourage you to go out and buy more appliances, especially toasters and hair dryers. They're always good, so you should have 2 or 3 of those in the house. So, you want to have all those kind of things out there. What we're doing, though, tonight to make this work, at least we hope it does, we were having a little bit of difficulty why we weren't ready a little earlier, is that we're doing something called backfeeding the transformer. Do we all know what backfeeding is? Okay, now you're working with me, so I know that some of you might, some of you don't. One of the things you people have to be aware of when you go out into the field to possibly help us with wire-down situations is something about backfeed. Backfeed is simple. It's that we're fooling the transformer. The transformer is dumb. Okay, it has no brains. and it just hangs there. You know, they're commonly called a trash can hanging on the wall when you people call in and tell us there's a problem. But anyhow, this transformer has wire in it. It's in a coil, and it's in oil. This tank is full of mineral oil. Now, I'm sure that several of you might have remembered a little something called PCB over the past. Well, Detroit Edison didn't really buy PCB transformers. And the industry, PCB, is an excellent fire retardant. It really is. And some utilities bought transformers with PCB in it. That's what they wanted in their transformers. Well, we got what was called residual PCBs, because if you can imagine two tanks, one PCB and one mineral oil, and they turn the spigot on out here, PCB runs through the pipe, and he's done filling yours up. Now he's going to fill mine up, so he uses the other pipe, and the PCBs got into some of our transformers. Yeah, we've got some out there that we bought that way because that's the way they sold them. In the older times when Darrell first hired in, that was the kind they were buying. But hopefully we got most of them out of the air now, and you should see little blue tags on them anywhere that you go. But anyhow, the transformer, we're taking the house voltage here, which is 220 volts, and we're backfeeding this transformer. In other words, we're putting the 220 volts into the low side or the secondary side of the transformer. Transformer being dumb puts it back out over here as high voltage. Okay, just the opposite of what it normally does. Okay, that's backfeeding. Now what can happen out there in a storm situation or tornado or whatever you might be involved in is we can have people with generators. And people with generators that don't want to spend the money for that electrical box that they're supposed to do by law. It's a switching box that you turn us off and you turn you on. Okay? If they don't do that, they can backfeed our lines. Comes up through the secondary service that feeds your house, through the transformer, and back out on the lines. Now our linemen go up there, assuming that everything is dead, and they tie into that, it could kill them. Okay? So backfeed is very, very important to us and to you. As you're on site out there, in whatever situation you might be in, you want to be aware of backfeed. Right? That's right. Okay. So that's what we're doing. We're backfeeding this transformer with your house voltage, and we'll be working with 4,800 volts up here tonight. Okay? So if we set off these smoke alarms here, someone's covered them up for us, and if you get wet, I'm sorry. Now before we get into the high voltage, I'd like to just talk to you a little bit about low voltage. And we're more concerned with low voltage, of course, in our business than we are the high voltage, because we know more people are killed with low voltage than high voltage. Why? Well, it's all around us, isn't it? It's in the lights, it's in the plugs on the wall, it's everywhere. And when you go down and you buy your appliances today, unless you buy something called double insulated, you probably come home with a plug that looks like so, and there's 3 prongs there. Now, a good many of our homes only have sockets that have 2 prong holes, right? So what do we do with that 3rd prong?
Cut it off.
Cut it off. What the heck did they put it on there for anyhow? It give us headaches, right? You know they put that on to save your life.
That's right.
Okay? It was put on there to protect you from dying. All right? Now, because my OSHA follows us around sometimes, my plug has 3 holes in it, but we're going to pretend it doesn't. And to use my drill here, because I'm the kind of guy, you know, you see the tags on your pillows that says, do not remove this tag under law, okay? If you take that off, do the police come get you or what?
No, your parents don't.
Your parents do. I was always wondering, because I never tore them off.
I always do.
You know, and I was the same kind of thing about my plugs here. I wasn't sure if I took that plug off, if the cops come get me or something, you know? So I went to the hardware store, and I got these handy-dandy little things here that are called cheaters. I think it says adapter on the paper, but we call them cheaters, because you're cheating yourself if you use these things, okay? Now, this particular one has just a little metal thing on here, and I'm not sure why they put that on there, because I always scratch myself with it or even cut myself with it, and I might take that off too, right? You know, they're wasting all this stuff, right? But if you were to read on top of there, if you had 3 or 4 magnifying glasses and good eyes, it says caution. Do what? Do what? What does it say?
Do not remove. Do not remove.
It says, you haven't read them, have you? It says this little metal tab must be placed under the screw on this little box.
Oh, yes, yes.
Remember reading that? Okay. Now, you might as well whistle in the wind as to do that, unless this box is grounded. Okay? It has to have a ground wire running from it to the cold water pipes. You know that. Okay? There's no need to waste my time putting that on that screw, is it? Huh? Okay, so we're knocking these things off pretty good tonight, aren't we? All right. Now, there's another kind that comes out, and it has about a 3-inch wire on it. Do you know why they put that 3-inch wire on it? It's to carry it and twirl it as you go. Okay. Now, since my plug here really only has 2 slots in it, and you know, I had 3, although I've got it here, I'm going to plug that in, and heavens, I can use my drill now. Okay. Now, because of what I'm going to do, and you see this little word on there, energized, I've got my trigger held back with a piece of tape. But I don't want to touch that in a minute or 2, okay? And my off-on switch is in here now. And then this other thing here, this other switch is something, how many of you are electricians?
How many electricians or understand electricity?
How many okay, how many understand electricity?
There's a positive and a negative, and I'm not too positive which one's a negative.
I'm never proud. But you're right. He's all right. He's right on. Because most of us are electricians. Okay? And my cord on my drill here was kind of frayed, you know. I've been carrying it around by the cord and all the kind of things. I treat my tools pretty rough. I don't take care of them. You know what I'm talking about? Smiling, shaking your head. Sure, you do it, don't you? Okay. So I've got to change the cord in my drill. Okay. Simple job. There's only 2 wires, right? Anybody can put 2 wires in there, can't they? Okay? So now when you take all this apart, you know, and you lay it down on the workbench, and there's a couple of screws and maybe a spring in there that popped out while you're doing that, and well, you might. Maybe we forgot how to put those wires back in. Was the black one over here or over there? Okay, well, we don't know. It doesn't matter anyhow. It's 110, and we only got 2 wires to worry about, right? It'll kill you. It'll kill you deader than hell. Okay? How many of you have received a shock before?
Oh, yes.
A lot of electricians out there.
The truth is coming out. Okay. How many of you have taken the tool you were using, whatever it was, and you couldn't turn it loose and it bounced you all over the floor? That's when you've received a shock. That other stuff is a sensation that you said, son of a gun, right? Okay. Close. Close, okay. So what we're concerned about is low voltage up to about 600 volts. 600 volts and below will contract your muscles so that you can't get away from it. All right? Now, we've had a man killed in that very situation took the drill to the tool crib, and the man in the tool crib replaced the wire. You know, certified electrician, okay. And got the wires crossed, and his next job was on a steel stairway. Took 2 days to figure out what killed it. They finally took the drill apart and they saw the wires were reversed. Okay, so you got the message, right? All right. So I'm going to turn my drill on, and it's kind of not noisy. And I'm not going to let it run like it used to. And then I'm going to put the ground on it, and we'll see what happens. Now you might have noticed that I've got a hot dog hanging over here. Okay? And that's what you don't want to be, is a hot dog. So if you do funny things with electricity, that's what you look like. You're a hot dog. All right? And if I let this run long enough, you would see that cook. All right? But we're not going to do that. Trust me. All right? My drill is working. I can hold it. I can drill. I can do all kinds of things. Okay? No problem. Any different? Still works. Right? Do I touch it? Not good. On the off. You got the hot dog. You don't have to go there. Okay, you can feel just a little warmth in that. She's starting to come. Okay, just a little bit. Right?
A little bit.
Okay, just a little bit. So what we want you to do in your kitchen, in your bathroom, and you guys in your workshop is to go out and spend $10 and buy a GFI, ground fault interrupter. Okay? Sometimes they're on sale for $7.98. And you put these in, just like any other plug, and you can do it. But the thing that you got to remember, it has to have a ground to work. So you still have to have that ground wire in there. Now, if you put it in, like I say, it probably cost you maybe $7 or $8, maybe 10, whatever. But if your electrician friends put it in, probably cost you $210. You know, such a bargain, right? Okay. But let me show you what a GFI does for you. Okay, the same scenario here we've got. And it has 3 slots in it for my plug, and I can plug right in there without using the adapter. And if you were to check into that ground fault interrupter, it recognizes a fault in 1 nanosecond. Now, how many of you heard of a nanosecond? Marty, you know. So how many decimals?
I don't know, but the distance an electron travels is 6 inches.
9.
It's 9 decimal points. Okay? Nanosecond. Very small. All right? It recognizes the fault and takes care of it. So we got the same scenario. We got a drill. Okay? And the ground fault interrupter took care of us and worked very nicely and protected us. Now, how many milliamps does it take for you to feel electricity? Do you know?
Not very
Okay. Let's pretend that we have $1,000 stacked up here. Probably like that, right? And that $1,000 will buy a few things. We can go to McDonald's and probably get a couple hamburgers and a Coke, right? Okay. But if you got that $1,000, that would represent an amp. And if you reached in the pile and you pulled out $1, which is very small, isn't it? Very small today. That's a milliamp. Now, 1 milliamp, you start feeling electricity. That's when you guys got the tingle and you said, oh boy. Okay? But if we get up somewhere between 4, maybe to 10 milliamps, it may render you unconscious or take your life or do a lot of things to you. Anything over that will kill you. It will take your life. We're talking about a very small amount.
doesn't it depend on like what part of the body that current goes through as to
It
whether?
depends on lots of things, and yes, you're right, okay? But if your body is moist, if your body is dry, if the humidity and so on and so forth, but the average, okay? That's what we're talking about. And especially, a good point, is if it goes across the heart. It throws the heart into something called fibrillation, and you can't change that. You must know that as first aiders, right? All you can do is maintain a circulation. Okay, enough about low voltage. Any questions about low voltage? You use it every day. You made coffee this morning, you probably had a little toast or whatever, and combed your hair with a brush and all those things. I think you was first.
Those little cheer plugs like you were using up there, you should use those, is this is what you're saying? So what would you do? Like, okay, I have some things at home that use the three prongs, and I only have two.
Right? You're not gonna like my answer.
Pay an electrician to
Pay
come.
electrician and get updated, yeah.
It's more than likely that box is grounded, so putting that little wire on there, or that little eye that's on there, isn't gonna give you that third wire like you need, so you need that extra ground wire.
Well, I didn't know.
So you gotta find a good friend that's an electrician. Yes, ma'am.
How can you tell if a wire's defective or not, especially in the lamps? And you
Okay.
can't tell if a wire's defective or not. Even though the light's still on and it's, or anything, you're not home and it starts sparking, then you turn on the
Oh,
house.
if it's sparking, you're
Yeah.
dead.
Where was it sparking? In the
It wasn't-
wire?
It wasn't, I've seen it on 911, his house caught fire during a spark. The lady left her house and it was just, she didn't know anything was false wiring or not. She didn't know until 3 years later it was removed.
I'm sure that probably if you got into it, the cord had been cut or caught in the vacuum cleaner at one time and rolled up in there or something along those lines and some damage had been done to it.
That's two on,
Pardon?
that's two on.
Cats chew on it, kids chew on it. Yes, ma'am.
No, when I got my treatment machine, it came with that plug, and they told me I had to use it.
But
And
they
the
did-
housing over there, they don't have, I don't know if they only got the two prongs.
if they told you that, they forgot to tell you that it should be grounded. Okay? It works fine, okay? It works fine. And there's probably a billion of them out there because the manufacturer wouldn't make them if he didn't make money, all right? So what we're telling you is there's a possibility if you don't ground that of damage to you by touching the equipment, okay? You just want to be aware of that. Yes, Joe?
It was a good, for instance, like everybody that goes downstairs, basement or whatever, has their washer and dryer, and you use those cheater plugs. If anybody's ever maybe grabbed a hold of their washer and maybe just accidentally touched the dryer and felt a little bit of a warming tingle, that's one of the reasons why that should be grounded on all your appliances downstairs.
Absolutely.
What you find like on a dryer, that's a little bit different voltage. On a wash machine, if you get a poke out of that, you pull that plug up and turn it over, because then that's putting the ground where the ground should be.
Right.
What you're doing is making the outside of that the hot part, the inside is the ground, and it still works.
Okay. Hey, I'm going to go Hollywood on you now and wear sunglasses up here. They're safety glasses that we furnished all of our employees. The lines trades, people work outside basically get sunglasses. And the guys that are inside usually get just a clear, what we call Plano glasses, unless they have a prescription. And then we will make their glasses for them. But if I didn't, and I was up here playing with this for a while, like I will be doing in a moment,
No?
not now. But I'd have a little seniority on him, so you guys help me watch him. But I lost my thought now.
Yep.
Sunglasses, thank you.
Where's ours?
You're safe, you're safe, you're all right. But if I didn't, I'm sure the electricians in here will tell you that About 2 o'clock in the morning, it feels like somebody threw a couple of grains of sand in your eyes and then rub them. Okay? So if you don't mind, I'm going to hide behind the glasses. I told you what we were going to be working with up here was 4,800 volts. And that's one of our distribution voltages. We have two. We have 4,800 volts and 13,200 volts. And these may be in your backyard. The transformer that hangs on the pole is identical to the little green one that's in the box that sits on the ground. It's just a different container. Okay? It's the same animal. So this is our transformer here that we're backfeeding, and then we have a secret capacitor in this can here that's hooked up. And please don't try and do anything that I'm going to do tonight. What we're going to do is very unsafe. All right? Now, one of the things that we have to do on occasion is go out and talk to people that have operated their cranes or a lift of some kind close to our equipment. And we get out there and the guy will say, yeah, I know. The law says I'm supposed to have 10 foot of airspace between my equipment and your wires. And that's true. That's a federal law. Okay? Unless you are utility trained, you cannot come closer than 10 feet to our wires. But I was 10 feet away, and your electricity jumped out and burnt my boom, and now you owe me a boom, Detroit Edison. So we know that our voltages, the two distribution voltages we have, don't jump. And I'd like to show you that. I've got a piece of insulating board that's 1 inch on one end, 1/2 inch on the other, and if I turn it sideways, we're looking at something about 1/4 of an inch. So Daryl, if you give me some juice. Now the little lights for me basically to tell if the machine is on. But you can see that if I put these 1 inch apart, the electricity is not jumping. There's nothing happening here. And I can stay here all night doing this and nothing would happen. If I turn it to the other end, the 1/2 inch end, I can still do that. Okay, electricity does not jump at this voltage. If I turn it to the 1/4 inch side, I can hold it there and electricity is still not jumping. Okay? We know that we have to make contact. And after we make that contact is when damage is done. So we're going to test the circuit box, Daryl. We've made the contact. Now we're going to break it. This is 4,800 volts. Have you ever seen our product before?
Not quite that well.
Okay. If you go out on a situation that you people may be involved in, that's what you could see. Or the wire may be laying there doing nothing, just laying on the ground, and you think it's dead. Don't believe it. Okay? The only dead wire that we are concerned with is in the warehouse, and we're not sure about that. Okay? That's the way we treat it. Now, the temperature here can be upwards to 30,000 degrees. In fact, a lot of the steel companies, and all of them in our area, use electricity to turn their ore into steel. They use electricity today. We can make it as hot as they want it, and we can turn it on right now, where the other sources have to heat up. Now, something that we always encourage our people to do is to wear the proper clothing around electricity because it is so hot. Now, you ladies all like polyester, right? Because you can throw it in the washing machine and hang it up, put it on the old man's back, send him to work, and he looks like $1 million. You didn't have to iron too much, did you? Okay? Now, polyester has been around now for what, 30 years or thereabouts? It's great. It's in practically everything that we use today. And even blends, they're mixed up with other things. And this piece that I have here is 60% cotton and 40% polyester. 60% cotton. Now, why are we talking about cotton? Cotton is a natural fiber. And natural fibers don't burn as bad as polyesters or synthetics. In our business, if we have a flash, it's momentary, but our clothes catch on fire and continue to burn. And we can't get them out quick enough without it doing a lot of damage to your body. Okay? Let me show you polyester. This is dry. Okay. We haven't done anything funny to it. I'll tell you when I do funny things up here. But I can pull it across, nothing is happening. Would I do this barehanded? No. But I want you to watch how quick this ignites and the black smoke that comes away from it. Okay, now this I can put out reasonably easy in my glove. Okay, and I'm safe as far as the fire is concerned. How would you like to have a shirt on and have that stuck to your chest? Okay? That's what happens. Now, some of you are wearing the checkered shirts or designs in some of your shirts. Did you know because the heat is affected differently by color, it would even tattoo you? You can get a free tattoo.
Cool.
Now, I've had an opportunity, if you want to call it that, of being in the room with two guys that have been badly burned. I didn't recognize them and I knew them well. Okay? And what they do is they pull as much as they can off without any kind of medication because of why, first aiders? We could go into deep shock. Okay. So they want you to remain conscious because we don't know what's wrong with you totally. So they get that big portions off, and my glove is not a real good example of skin, but they have to get all this residue off with tweezers. Okay, and they soak you in a very big tub to do that. You know somebody that's been burned, talk to them. Okay? Now this could even happen if you're out there this summer flipping those burgers. Okay, and you got that cute little shirt on that you got, probably gave it to you. Okay? And got some kind of a cute saying on it, made out of polyester. She knows, she sends you up. And you flip that and the grease comes and you catch fire. You guys that are welders, you guys that are electricians, okay, you want to think about this. I got a piece of old J.C. Penney blue jean material, okay, 100% cotton. I want you to watch the abuse that this takes. Okay. Again, I can pull it across without any problem, but watch it take the abuse. Now, Daryl. Now, once again, I can take this and I can put that out reasonably easy in my glove here. Bad thing with cotton is it smolders and smells good.
Take this cover off.
Yeah. But wouldn't it be better to wear cotton than polyester? Okay. See the difference? Now, how many of you guys work at Edison? I know some of you do. Work at Edison? Who? You leave? Okay, well, I'll tell you anyhow. We have a new law that's just came into effect, or it will be in effect on June 1st. It looks like we, in the electrical business, and the distribution and generation of electricity, are going to have to wear fire retardant clothing. Okay, it's come to that. Federal law has seen enough accidents that they're going to require fire retardant clothing. Now that's all kinds of stuff, 100% cotton treated with something called Proban. Are there any firefighters here?
Retired.
Retired?
I was 18 when I got in the fire department, I was 28 when I left. 10 years.
Okay.
I've got a 2-year-old son, I gotta worry about him.
Okay, good. But these guys wear something called Nomex. Probably the best thing that you can buy for protection. A jacket costs somewhere between $400 to $600. Okay, very, very costly. So I guess what I'm suggesting is get ready to pay more on your bill. Okay. One of the other pieces of equipment that we are concerned about is our footwear. You may or may not know that our poles are ground. Now, most people think wood, you know, no problem, no electrical problem there. You can climb that pole and do whatever. But they are ground. Now, our linemen have to wear a lineman's boot. Now, you would certainly think a lineman's boot would be insulated for a lineman, wouldn't you? Okay. They're not. All right? It's nothing more than a good work boot. Now, a lineman's boot has to have a steel shank from the ball of the foot to his heel, and he stands on that all day. If you think about what he's standing on the pole, or a ladder. If he didn't have that in there, he'd look funny walking down the street. Okay? So he has to have a good steel shank in there. He has to have good leather, good support for his ankle, and all of those kind of things. And any guess what he pays for his boot?
$175 to $200.
$175, $200 for that pair of boots. Now, this guy that we've got on our crew today is a hot dog, okay? You have one that you know about? You know, the guy that doesn't believe in rules, he's got the answers all the time, okay? Well, we have something called a dry weather overshoe that I'm wearing right now for protection, and I'll show you that in just a minute. But this guy went up the pole this morning, got his feet a little damp out there in that little frost that we had, okay? Boy, that make it go off. Okay? Now, we probably had a fatality there of our lineman, and if he had only followed the rules and wore the protection that we gave him in the form of a little bootie, a little slipper, that's called a dry weather overshoe. Now, when you take this out of the box, it's good for about 17,000 volts on the bottom, okay? And if you take good care of it, it'll take care of you. If you take care of... I told you. But
White must have woke up.
Wheels are great, man.
I would probably meet the firemen from Fort Huron.
They'll come and send you greetings.
I'm sure they will. But this little boot is designed for those 90-degree days.
Mike attended this class.
There, okay. Don't do that again, Darrell. Now, this boot is dry, although the leather boot I wet. Okay?
Well, that's all right, go ahead.
You can see that the guy is protected now, although his leather boot is wet. Okay? Just by wearing his protective equipment. Okay? Now, relate this to your job. I'm sure there's all kinds of trades in here. Whatever your job is, you have some rules and equipment that you must use and maintain. And if you don't, it could let you down, right? Now, I've got another one of those little overshoes that we've been soaking up here for a few minutes. And both of them were dirty. And dirt, of course, makes a good conductor. But when you're sitting at home and you're waiting for the Edison lights to come back on, and you're probably calling us a few names, friendly names, I'm sure. There's some poor guy hanging on the side of a pole out there that's feeling something called tracking. This is not no track. I don't know if you can see it in all the light.
Yeah.
That's called tracking. Now what's happening, the electricity is going across the moisture. Did you take care of it?
Yeah, it's all set.
Going across the moisture on the shoe and the dirt and what have you, trying to get back to the other probe. Okay? And believe me, it's very uncomfortable, and that's when you say, why in the hell am I doing this? Okay? But that's tracking. Now, we have a firefighter in here, although he's retired. I'm sure he'll recognize this. Okay? And we were in a fire hall not too far from here, within an hour's drive. And they just had a firefighter 1 class, and that's where the guys become firefighters. Okay? And this is a time when you feel your oats kind of, you know, you're tough and all those kind of things, right? Firefighter 1?
Yeah, I remember that.
Okay. And this young man was insistent that his boot was as good as any of our tools, and he could move any of our wires when he's out on the job. So we asked him to bring his boot up, and I asked him, I said, when you're wearing this, because they don't wear shoes in here, this fits right on their foot. I said, does your foot get wet inside? Oh yeah, sometimes. So I took a handful of water and I put in there, as I did here. And I said, we'll put it on our scientific machine here, and we'll test this boot and see what might take place, okay?
One dead rookie.
Luckily, he wasn't wearing it. But what this young man didn't realize was that in going in the backyards or wherever he was fighting fires, he had stepped on some small nails. And when we started this, you couldn't see the holes, okay? And that's why he had faith in his tools. And as we do the demo, we make the holes bigger because they burn. But I think you get the point. This man had faith in something that he couldn't test, that he didn't check, okay? Now, some of you may use rope in your business. We do. We use a lot of rope. And I've wet this rope. And again, this is not unreal if you were out with us on a good stormy night. And this particular piece is only this long because my arms are only that long. And this is a typical hand line here. This is the rope that we send stuff up and down the pole with. And so if you were out there tonight, a good stormy night, and you were running the hand line and sending things up and down the pole, and I let it go across one of the live wires, do you think you would feel that? Yeah. Let's see. Now remember, this is only as long as my arms. If it was long as that hand line, which is 40 foot, it would do the same thing. This piece of rope is conducting 4,800 volts. Okay? Anywhere we touch it. And what's the power in electricity? It'll dry that rope right out, and eventually it'll arc over. Okay? So if you're using any kind of rope or line, you want to be concerned about working around our wires. We have contractors, and I'm sure nobody here would do it. Sometimes we'll throw little ropes over our wires and pull it a little ways over, you know, to get it out of the way of a truck or something. Don't do that. I've got a piece of cotton string I loosely put on my probe here. I've dampened it. It's hard to see, but that's 4,800 volts. If you don't believe me, come up here and I'll let you hold it. Now it's that time of year when we're going to be flying kites, and I'm sure you've heard Isaiah say, okay?
Look up.
Look up, okay? I beg pardon?
Pass the ball.
Pass the ball.
Basketball.
This is 4,800 volts going through a piece of kite string. You kids see why we don't want you flying kites around our wires? Now, one of the things high voltage does is draw, and if it's steady enough, you'll see the string come over. See that? Now, what happens, guys, is when the TV screen gets all dusty, that's not Ma's fault, okay? Don't jump on Ma for not wiping the screen off. That's high voltage in there drawing the dust, right? Okay. Now we, as you tried Edison, this past couple of years, you may have seen a lot of contract crews on our site. We've spent over $200 million in the last year upgrading our lines. You might remember a little storm that came through, I think, a couple years ago. And seems like the Michigan Public Service Commission came by and said, shape up or ship out. Well, we've spent that money, and we're still spending it to upgrade our lines, better cross arms, wire, and all those things. And it's paying off. Our outages have gone down. But the thing that really causes a lot of problems is this thing here. Now, what would you call that?
Tree.
A lady the other day said switch.
Yeah, that would work.
It would work.
Yeah.
Especially for scouts, I suppose.
You bet.
Okay, get their attention. Okay, $36 million we spent in '93 to trim little things like this. Every 3 to 4 years, we come around and check every tree under our wires. You know that? Every 3 to 4 years. What we love to do when we come and ask to trim your tree is to trim it about 2 inches off the ground. We don't have any more problems with that tree for a while. Let me show you what might take place with this tree limb here. Now this is a Porturan crabapple. Once again, this is only because my arms are so long. But think about that tree, and how many times do we read in the paper in the summer when the guys are playing golf? Where do they go? Under a tree. Okay. Let me show you something. Now this is just cut at random, no special, not any dirt or water or anything. Okay, Darryl. I can watch my upper limb up there. If you're close enough, you should be able to see that. The front row can shake their heads in there. Okay. Anywhere that I touch this, we're conducting 4,800 volts. Okay. Darryl, I'm going to come at you, so watch it. Okay. Now we're concerned about this because we don't. That's my finger. We don't know when this is going to happen. This may happen in an hour. It may take a month. We don't know. Let's see how long it takes us here tonight.
Turn that fire alarm off.
Awesome! Firecrackers!
Right through the tree.
Dude, can I take that home?
They should have took care of those VCR lenses.
What about evergreens? Oh, there wasn't any around here close to steal a limb on, so we don't have one. But evergreens are great, and when we buy them, they're usually about yay big, right?
Yep.
Where do you plant them? Yeah, of course. Right, because what you want to do is block the neighbor off, right?
Yeah.
You don't want to see him, or maybe it's the other way around, I don't know. But we plant them under the lines, and then about 20, 25 years, they get up just right, and we give them a crew cut. Have you ever seen an evergreen with a tree cut?
Yeah.
They don't come back. Please, when you're planting those trees, look up, see where you're planting them. Now, this is a piece of limb that we've had for a while. It's dry, we don't do anything to it. It was rubbed by a wire for a long time. You can see the misformed limb here. But this has something on it, where's my fireman, that we're concerned about all the time, and that's that black stuff called carbon. Nothing but carbon. Burnt wood.
Yeah, I can go home.
So anytime that you have burnt wood, you want to be very, very careful around electrical wires. How many of you have got a new deck? Treated deck on the back of the house? Okay, we all got one, haven't we? Well, this particular piece has just about had it. But when we started out with it, it was a piece of treated wood. And it's dried out on us. But how do they get the treatment in the wood? High pressure. And they use a vehicle to get it in, which is usually a water or an oil. Do you know your deck is very conductive for 5 or 6 months? Very conductive. We used to be able to show that with this piece of stick, but it's, like I say, it's had it. But the point now is, take a dry stick and move the wire. You ever heard that? It used to be taught. Take a dry stick and move the wire. People, there's no such thing as a dry stick outside. Don't ever try it. Don't mess with our wires, please. Now this piece is just a demonstration. Anybody from the gas company? It's okay, you can admit it. Well, the gas company has something called gas logs, and they sell these for fireplaces, right? They're very nice. They're very nice, okay? But we want to give them a little competition. So what we're going to do tonight, as soon as we're done with this show, we're going to raffle this outfit off. And you can set it next to your fireplace, put a flower pot on it, you know, or something, dress it up. I'll take it. But what I want to show you here is nothing more than carbon again, okay? And who can tell me what we generate our power at? How many, they call it hertz today, it used to be called cycles. How many cycles? 60 cycles, right? So if I were to put this on here, and we're close to the power plant, right? Okay, we should be able to count those cycles. Ready? All right, you ready? Here we go. 5960, that's what I got. You? Okay. Once again, nothing but carbon. Piece of carbon burnt wood will conduct electricity very nicely. If I were to say, cowabunga, dudes, okay, who am I talking about?
Raphael, Michelangelo.
Who are they?
Turtles.
Turtles.
Yes, Ninja Turtles.
Ninja turtles. Okay, where do the ninjas live?
Sewers.
What do they eat?
Pizza.
They live in sewer and eat pizza?
Is that a pizza?
No.
Turtle pizza.
This is a manhole cover.
Oh yeah, they push it up.
I used to bring a real one around.
The 2-ton one?
They weigh about 80, 90 pounds, and I got tired of carrying them around. But anyhow, would you believe that we have had a couple of our manholes where the lid has been gone, and it appears kids have been down in there playing? Okay? Now, our wiring in there is reasonably safe. But the concern we have are the gases that are in manholes. There are some gases that lay at the top of the hole, some gases that lay at the bottom of the hole. You get one breath, and they'll take your life. Now these holes that we found had pieces of old furniture in it. emulating the turtles, we think. Please, please, kids, don't go down in holes. It's so dangerous. It'll take your life so quick. There's gases in there that you won't believe. Before we even take this off the manhole, we go through these little holes on the top and test for explosive gases. Because as we pull this off and spark it, we send these things into orbit. Okay? Please don't go into manholes. Stay away from them. Now we've got a piece of fence here, and it's just a short piece. Many of us have homes that have fences that surround the house, right? And maybe they've even got a common fence post in the back so that the wire comes down across one end of the block and the fence at the other end of the block be energized. Let's see. Okay, Daryl. You bet. Okay? You've got some warning signs. Stay in the house. Don't go outside and lean on the fence when your lights are out. When your lights are blinking. When your lights are dim. These are all warning signs to you. Don't go out there when you're doing your job for the Red Cross and touch fences, whether it be a cattle fence, fence around the house, whatever. We've got houses that the fence post leans up against the house that has aluminum siding on it. The aluminum siding is energized, okay? And what happens there is the little nails melt and the siding falls down. Wouldn't that be a sight to come home to? Okay. I ran the probe along this wire, and it has some stuff on it, and we commonly call that what? Insulation. It's not. That's called weatherproofing. Okay? And it's on the wire for the wire's sake, to protect the wire. So don't think you can get close to it because it has this black covering on it. Remember, it's for the protection of the wire. Yes, secondary voltages coming into your house have insulation on the wires, but don't mess with it. Okay. All right, you're in the car and you just hit the pole for whatever the reason is. The wire has come down across your car. What do you do?
Stay in the car.
Stay in the car.
Do not touch anything.
Stay in the car and let the experts come get you out. Okay? All right, now we're going to go to the bad scenario. We have a fire on the car and you have to do something. What do you do?
Stay in the car and jump.
No.
Break the window and try to get out the window.
Why you break the window?
Put it in reverse.
Open the door.
Jump.
Okay?
Suppose you get caught in the falls over the car and you can't get out, you gotta go through the window.
Well, all right, you break the window in that case.
Keep on the door.
But let's say that you have the wire over it and possibly the fire, your car's caught on fire. Now the tires, they're made out of rubber, so they certainly would protect you, wouldn't they? Excuse me.
No.
The first thing that burns off the car is the tires, okay? They're made out of oils and steel belted. Steel belted. So what you want to do is open the door, and when you do, make sure it stays open. And you've got to control everything, and that's going to be tough. And that's up here between your ears. And you want to open that door, making sure that it'll stay open. Put your hands across your chest or behind you, wherever you're most comfortable with. Jump out of the car and roll away. I didn't say step and run, I said roll. Fall down and roll away. Now why do we say that? When I have this, okay, that's one reason. But if you all, and I'm sure every one of you have, gone to the pool of water, whatever it is, lake or whatever, and you tossed a rock in it, and the rock hits the water, what happens? The ripples go out, right? Okay. Electricity does the same thing. If the wire is laying on the ground, where does the electricity go?
Ground.
It goes all over. It goes into the ground and goes out in the ripples. Okay? Now, that's something called ground gradient or step potential.